Assalamualaikum and good night, everyone. Okay, I would like to continue about this example F2. Okay, we are going to determine the member and moment for this frame. This is sidesway frame. This is sidesway frame, and for sidesway frame we have 4 steps. Okay, so we have four main steps. So sidesway, it is sidesway frame. We have 4 steps. Step number 1, we have to calculate K and distribution factor. Step number 2 is part 1. This is part 1. Part 1, it is side. This is not side. No sidesway frame. This is no sidesway frame. Okay, so under this part, so we have to divide. We divide into A, B, and C. So we have 2A. It is FEM due to external loading. External loading only. Okay, 2B, it is end moment. End moment, we label as M0. We label as M0. This is table number 1. And 2C is the restraining force. Restraining force. Restraining force R. Restraining force R. So this is part 1. Part 1. Okay, no sidesway frame. Okay, so we move to next step. Step number 3. So step number 3 is part 2. Part 2. Part 2 is sidesway frame. Part 2 is sidesway frame. Okay, so this is 3A. For 3A is FEM. And this is due to sidesway. Due to sidesway. So okay, this is due to delta sidesway. 3B end moment. Sidesway frame delta prime end moment. M prime. And 3C is R. Okay, prime. R prime. Okay, and step number 4 is the final member and moments, and we calculate this final end moment based on the principle of superposition, labeled as MF. It is M naught plus R divided by R prime kali times with M prime. This is R prime times M prime. Okay, so this is actually all the procedure for 4 step. Start from K and distribution factor, and then 2 is part 1, 3 is part 2, and 4 final and moment. Okay, so all this is actually based on the principle of superposition. Principle of superposition. So it is based on this. Okay, it is based on this pin fix. We have here 30 kilonewton per meter. Okay, so looking at this is unsymmetry. So this is unsymmetry. So we have to analyze this. using moment distribution method. 4 step. Okay, 4 step. Number one, we have to step number one, we have to determine K and distribution factor, and this distribution factor will be used in both table 1 and table 2. Okay, so in order to calculate FEM, due to external loading only, we have to remove delta. So we have to remove delta by looking at this diagram. So the loading will actually push the frame to move to left direction. Move to left direction. So we draw the same frame, pin and fix the loading, but we have to make this as properly restrained frame by putting an artificial pin support at B, so that the frame is now properly restrained and there is no delta. The purpose is because we want to remove delta. We want to calculate FEM due to external loading only. Okay. And since this is principle of superposition, we have to plus another frame, same type, but this time it is only delta. So by looking at this, okay, the R have to be neutralized. So we will have R in left direction, so that R minus R, we get 0. So due to this R, there are delta. Okay, this delta. Okay, delta at B and C, and we assume that the sidesway at B and at C are equal. Okay, so this is the principle of superposition. So this is diagram A, diagram B, diagram C. In diagram A is the final end moment. This is what we want. At the end of analysis. Okay, in diagram B, we will have M naught, and we get this from table 1, and due to R and delta, there will be M. Okay, so this is actually the principle of superposition, because B plus C we will get A. B plus C we will get A. End moment in A is the final end moment. End moment in B is the end moment M naught from table 1, and end moment for diagram C is labeled as M, and we do not know the value. And we cannot calculate the end moment directly because the delta is unknown. So due to that, we have to introduce another diagram which is proportional with C, but we change the label. The label R become R prime, delta become delta prime, and M become M prime. So this is table 1. And table 2 means part 2. Table 2 is diagram D. So we have another diagram. Okay, we have another diagram. So this is D. Same with C, fix and pin. Okay, R prime. So this is D. Okay, diagram D. Okay. So the delta we label as delta prime. delta prime, both are similar, same value, same distance. Okay, and moment for this one, because this is table 2. This is table 2. So end moment for this, we label as M prime. So this is table 2. Table 2. Because we cannot assume delta, we cannot calculate end moment M directly. So indirectly, we introduce diagram D, where diagram D is proportional with diagram C, but all label R delta and M, we put prime. R prime, delta prime, and M prime. Okay, so due to this, we will assume FEM, and from the assumption, we will calculate another FEM for another member, and after that, we calculate N member and moment M prime, and we calculate the value R prime. Okay, before we substitute into the formula. Okay, so by comparing C and D, we get from C. Okay, this is C, from C and D, from C and D, from C and D, R and M. R and M. Inside diagram C, between R and M. Okay, between R and M. And from D, it is M prime, R prime. Okay, so M is equal to, we group R over R prime together times M prime, times M prime. Okay, so we substitute into the equation, the main equation, which we get from principle of superposition. Remember, it is A equal to B plus C. Okay, what is A equal to B plus C? It is M final. M final is equal to M naught plus M. Now we substitute M into this. So we get M naught plus R divided by R prime, M prime. Okay, so what is M prime? This is A. This is A. M naught. This is B. Okay, M prime. Okay, M prime, this is from D. Okay, from diagram D. Okay, so this is the concept of principle of superposition. So that is why at the end of analysis, we use M naught plus R divided by R prime times M prime. So what is R divided by R prime? Because it is based on assumption of FEM. So we have what we call as correction factor. Correction factor. That is why we have this. Why we have this? Because we do not calculate, or we do not analyze diagram C directly, because the delta is unknown. So we cannot calculate the end moment M directly. Indirectly, we introduce another diagram. It is called C. It is called D. It is also sidesway frame, but we use all prime symbol. So this one we can assume. So we modify back at the end. We modify back by comparing C and D, and we get M is equal to R divided by R prime times M prime. Okay, so since A is equal to B plus C, since A is equal to B plus C, and A is final end moment, B is M naught, and C is M. So we just substitute. M here. So we get M naught, we get MF is equal to M naught plus R divided by R prime times M prime. Okay, that's the concept of fixed end moment. Then we will focus on analysis. So by understanding this, so we are going to analyze diagram B and diagram D. We are going to analyze diagram B and diagram D. Okay, so diagram B is called as non-sway frame. So part 1. So part 1 is non-sway frame. How the frame look like? How the frame look like? In fixed UDL 30 kN per meter A, B, C, D, and we have pin here and R. This is the frame that we are going to analyze in part 1. In part 1. And we have part 2. Part 2, it is side sway frame. So in part 2, we analyze. Okay, this is A, B, C, and D. Okay, and here we have R in opposite direction, R prime in opposite direction. Okay, so this is part 1 and part 2. So part 1 is based on diagram B, part 2 is based on diagram D. Okay, so end moment from part 1 is M naught, and moment from part 2 is M prime. Okay, since we have to analyze here equation and we have to do column analysis, so we have to actually put the reaction here. Reaction. Okay, this is because this is pin, right? This is pin. Fixed, we label the free body diagram, the moment. This is fixed. Okay, so this is AX, AY. This is MD. This is DY. This is DX. So we have to complete also the sidesway frame with A X prime AY. AY prime AX prime DY prime DX prime and M D prime. Okay, so these are the two diagram frame. One is non-sway frame, another one is side-sway frame, and we analyze this the first one in part 1, table number 1, and we analyze table number 2 based on part 2. The second diagram, it is side-sway frame. Okay, so in the next video, we are going to continue this to start doing the solution. Okay, thank you.